A learning target from 9-1 was determine the slope of a line from a graph. So I'm going to draw in a simple graph here. This is our x, this is our y. Let's put a point or an ordered pair right there. And another one up here. Connect them with a line. Now if you want to, you can draw in your stair step from one point to the next. And then remember, we're counting rise over run. Rise is our vertical change up and down. Run is our horizontal change from side to side. And I know that this graph is positive because I'm increasing from left to right. I'm going upward. Okay? And I'm going up 1, 2, 3 spaces. So my rise is 3. And I'm running 1, 2 spaces. So my run is 2. Now, if possible, we would always reduce or simplify our fraction, but in this case we cannot, so this would be our final answer here. Next, we're going to develop and use the formula for slope. So y2 minus y1 x sub 2 minus x sub 1. This right here is our slope formula. Oops, let me move up the paper for you. And let's write down two ordered pairs. 0, 9, 4, negative 8. And I always label them to help me, or you could use different colors, or you could circle and underline, whatever works for you. X comes first, Y comes second, just like the alphabet. Same thing with the next point. This gets 1s, this gets 2s. Okay, in our formula, y is in the numerator. So it's going to be negative 8 minus 9. So you owe one person $8, you owe somebody else $9. So we're already in the negative and we're taking away more. So it's going to be negative 17 over your x2 minus your x1. So in this case, it's 4 minus 0, which is just 4. And negative 17 over 4 doesn't reduce or simplify, so we just leave it. Nine two, calculate and interpret the rate of change. Oops. For a function. So in 9.2 we talked a lot about Margot, and there was a lot of story problems because we use the word rate of change when we're talking about a real life example. So let's draw in a graph here. And let's go -1, 2, and 5 for our y values. And in our x's, let's go 1, 6, 11. So in order to find the rate of change, we're still going to use our slope formula. So we're going to calculate the slope between these first two. Y's go on top. So it's going to be 2 minus -1. I chose the second y minus the first y, divided by the second x, which is 6, minus the first x, which is 1. So 2 negatives here make a positive, so 2 plus 1 is 3. 6 minus 1 is 5. And 3/5 doesn't reduce or simplify. So my y values are increasing by 3, and my x values are increasing by 5. So 3/5 is my rate of change, or my slope. Okay. Now, if you wanted to, you could calculate the slope between these two as well. What's 5 minus 2? We get 3 again. Or, what's 11 minus 6? We get 5 again. Okay, so again, the slope between any 2 points on the line is the same. So it doesn't matter which 2 you choose. Another learning target we had was to understand the connection between the rate of change and slope. They're the exact same thing. They're synonymous. So if I told you that our rate of change is we're earning $10 per hour, and I said, what is our slope, or what's our m? You would say, it's 10. Or if I said our slope, we're going down 1 over 2, you would tell me that our rate of change is what? -1 over 2. The exact same. So they're always the same here. All right. A learning target from 9.3 was show that a linear function has a constant rate of change. Okay, so usually we do this from a table. So x and y. And let's go 5, 10, 15, 20. You might already see a pattern. Just maybe. So let's find the rate of change or the slope between these 2 points. So we're going to take -12 minus -11. What do we get? 2 negatives turn into a positive. So -12 plus 11 is -1. So from here to here, I went down 1, okay? And then 10 minus 5 is 5. So from here to here, we went up 5. So this doesn't reduce or simplify. So this is my answer. That's my slope or my rate of change. And let's calculate it again. Because we haven't fully answered the question. It didn't say calculate or tell me what the rate of change is or what the slope is. It says show that it has a constant rate of change, which means that the rate of change is the same. It's consistent. It doesn't change. So we got to see if that's true or not. So we're going to take negative 13 minus negative 12 over 15 minus 10. Two negatives turn into a positive here. So negative 13 plus 12 is negative 1. And you could always plug this straight into your calculator if you wanted to with the two negatives. Okay, it's totally up to you. 15 minus 10 is 5. Are they the same so far? Yep. But let's calculate it one more time. So the second one, negative 14 minus negative 13, 20 minus 15, we get negative 1 over 5 again. So we're going down 1, up 5. So it's the same. So does it have a constant rate of change? I would say yes, it does. Why? Because it's negative 1/5. So bonus question. Is this linear? Does this form a straight line? Yes. Why? Because the rate of change is constant. The rate of change is the same. All right, next one. Understand when the slope of a line is positive, negative, 0, or undefined. So I am going to draw X and Y, 4 of these. And on these coordinate planes, I'm going to draw lines, and I want you underneath them to write whether they're positive, negative, 0, or undefined. So this graph is 0. This graph has a positive slope because it's going up or increasing. This graph is a vertical up and down line, so it's undefined. And this graph has a negative slope because it's decreasing. It's going down. All right, the last learning target that we covered says identify functions that do not have a constant rate of change and understand that these functions are not linear. Okay, so again, we usually look at these in a table. So I'm going to draw another T-chart. So there are numbers. And we're going to use our slope formula. Our y's always have to go in the numerator. So we're going to look at our y column first. Let's calculate the slope between these two. So 4, the second one, minus 30 over, actually let's do, what is 4 minus 30? Negative 26. And then we're going to do these two. The second x, so negative 1 minus a negative 3. So it would be negative 1 plus 3, which gives me 2. Ooh, does this simplify or reduce? Negative 26 divided by 2 is negative 13. So this is our first slope or rate of change. And now let's calculate it between these two. So the second one is negative 1 minus 4 over 0 minus negative 1. Negative 1, take away 4. We're in the negatives. We're taking away more. It's negative 5. 0 plus 1 is 1, and this just reduces. So these do not have a constant rate of change, or they have different slopes. So would this be linear? Would this form a straight line? No, because they have different slopes. It's not a constant rate of change. So because they do not have a constant rate of change, they are not linear. They do not form a straight line. I'm going down 13 over 1, and then I'm going down 5 over 1. It does not make sense here.